Welcome to Unit 8, Lines and Planes, Lesson 4A, Intersections of Lines in Two Space. This is kind of an introduction to Lesson 4, which is actually intersections of lines in three space, but we've looked at this in grade 9 and grade 10 math, and now we're going to continue it in calculus and vectors. So lines in two space can intersect in three ways. Remember grade 10 and even grade 9. Classify each system by determining the number of solutions. So we're going to go through each of the three ways they can intersect and how they look in vector and scalar form of an equation. So here we go. Here's the first one. So this is really back to grade 10 or grade 9 math. I give you two equations here, two scalar equations of lines, which are shown here. The first method is do by graphing. So for this, what I would do is find the x and y intercepts. So x-intercept here. Y is 0, so I have 4x equals negative 12, and so x equals negative 3, so on x equals negative 3, I'm going to put a little dot. And then same thing for y-intercept, I'm going to do x goes to 0, so negative 6y equals negative 12, so y equals 2. So I put a little dot on there, and then I graph it like such. There we go. So there's my line. I'm going to do the same thing with the other guy, so here we go. Line 2, so again, 6x equals negative 18. Divide both sides by 6, I get x equals negative 3. Oh, look at that, already got the point there. And then also I'm going to do it with 0 for x, so solve for y, so negative 9y equals negative 18. So, So y equals 2, and look there, the same point for both. And so what does that mean? That means one line is on top of the other. That means that it's coincident. So the lines are coincident, which means there are infinite solutions. So that's method 1 by graphing. That's really grade 9. Grade 10, two equations, two unknowns, use substitution and elimination. I'm going to go with elimination here. So I'm going to do, looking here, I'm going to take line 1, so 4x minus 6y minus 12, and I'm going to multiply this guy by, I'm going to make the x's the same, so I'm going to multiply this guy by 3. So I'm going to have 12x, if I go back up here, minus 18y is equal to, up here, negative 36. So this is line 1. And then I'm going to go down here, I'm going to take this guy here, line 2, and I want to make the x the same, so I'm going to multiply this guy by 2. So here I'm going to have line 2, 12x minus 18y equals negative 36. X is the same, so I'm going to subtract, same sign. So here I get 0, here I also get 0, and here I get 0. So I get 0 equals 0, which is a true statement but useless. What does this mean? This means there are infinite solutions. So that's really a grade 10 method. Grade 9 method here, grade 10. Here we go. Use solving using geometry. Examine the normals of the lines. Are they parallel? So normal 1, looking at the a and b value, is 4, negative 6. And normal 2 is 6, negative 9. And if I write ratios here, 4 over 6 and negative 6 over 9, negative 9, sorry, and these two are equal, so are they parallel? Yes, they're parallel. Why? Because the ratios of A and B are the same. If no, that means that they're not parallel, that means there are one solution. But if yes, so if yes, which is where the fact we're at, so if yes, I check if line 1 is a scalar of line 2, and we could see here in method 2 that they are scalars, because I multiply the top by 3 and the bottom by 2. I can see that they're scalars of each other, so that means the lines are coincident, which means, what does that mean, Mr. Wells? That means infinite solutions. If they're not, that means there are no solutions. They're basically parallel, they're not coincident. In our system here, we actually have infinite solutions. Alright, there's the first one. So really, we're focusing on method 3 because that is calculus. Method 1 is grade 9, method 2 is grade 10. Here we go. Now this one here, really, these three methods are all calculus, because we're going to graph using a vector form of the equation. So here's my equation, line 1, 1, 5. So I know that point 1, 5. So 1, 5 is right about here, right there. And then I know the slope is negative 6, 8. That means I'm going to go 6 to the left and then 8 up. But you can see it doesn't fit here, so I'm going to reverse it. I'm going to go 6 this way. So I'm at 7, and then 8 down. So I'm at negative 3. And so I get another point right here. There we go. All right, so that means now I can draw a line here. So to draw a line, I'll take my line, which looks like this. I want it to go both ways. There we go. And I'm going to draw a line through this. So here we go. Let's see if I can do this. There's my line. All right, let's do the other one. The other one says start at 2, 1. So 2, 1 is right there. Where are you, sir? There's 2, 1. And then the slope is, or the direction vector is 3, negative 4. That means I'm going to go 3 to the right, 1, 2, 3, and then 4 down, 1, 2, 3, 4. So I should have another point right about there. Beautiful. And I'm going to draw a line here. Here we go. And let's see if I can, oh, that's not what I wanted. Let's try this again. There we go, and I want, oops, I want this guy here. There, that's better. Oh, nice job. All right, so there we go, and we can see that these two lines, they look parallel. Not 100% sure, but actually if you look here, the direction vectors are scalars for those, so yes, they're parallel. It says so to solve algebraically, write the equations in parametric form. I'm going to cheat a little bit. There they are in parametric form. Again, if you want to go over that again, that's lesson 1. Equate the x and y variables, so here we go, I'm going to equate them. So I'm going to have x's, so I have 1 equals, or sorry, again, 1 minus 6s is equal to 2 plus 3t. I'm going to isolate here. So I'll bring everything to one side, sorry. So I'm going to bring this 2 over, so I have negative 1 equals, and then bring this 6s, negative 6s over, so I have 6s plus 3t. There's my first equation. My second equation, again, I'm going to equate the y's now. So I'm going to have 5 plus 8s is equal to 1 minus 4t. Bring everything over to one side. Let's see here. I'm going to bring my negative 4t over, so I have a positive value here. So I'm going to have 8s plus 4t is equal to, bring this 5 over, get negative 5, so minus 4. So there's my equation 2. All right, so let's line them up. Here we go. I will line up equation 1 and equation 2, but I want to make one of them the same. So here I've got a 3t, and here I've got a 4t and a 3t. So I'm going to multiply this guy. Multiply my equation 1 by, I want to make them both 12, so I'm going to multiply this guy by 4. And then I'm going to multiply this guy by, I want to multiply this guy by 3. So multiply equation 2 by 3. Why am I doing this? So I can get the t values the same. So here we go, multiply this guy by 4. So I'm going to have 24s plus 12t equals negative 4. That's my equation 1. My equation 2 multiplied by 3, so I'm going to have 24s. Oh, look at that. Plus 12t is equal to, and here I get is negative 12. So I'm going to subtract. That's going to be 0. That gives me 0, so I have 0 equals. Negative 4 minus negative 12 is 8. Of course, this is not true. That means no solution. So that confirms our method 1. We can see that they look parallel, and yes, that in fact confirms it. All right, let's go over here. Method 3, examine the direction vectors. Are they parallel? So again, here we go. I line them up. Or I just look at my direction vectors. Here they are. So I'm going to write them as ratios. So negative 6 over 3. That's my x value. And my other one is going to be 8 over negative 4. Are these equal? Absolutely they are, because they both simplify to negative 2 equals negative 2, which is totally true. That means that the direction vectors are parallel. If no, of course, there is one solution. If yes, so this is a bit different here. I'm going to substitute r naught. So my r naught is that point from equation 1 into equation 2. What do you mean by that, Mr. Wills? Well, I'm going to do this. I'm going to take my 0.15, substituting for 1 in, for x and y. So 1 equals, so again, I took this guy and I'm going to put it in for the x. So 1 equals 2 plus 3t. Solve for t. Bring this over, so I get negative 1 equals 3t. So t equals negative 1 over 3. All right, there we go. And what am I doing here? I'm just going to confirm. So I'm going to confirm that t equals negative 1 over 3 in the y. So the y, so I'm going to take this 5, put it into this guy. So I'm going to have here 5 equals 1 minus 4t. Bring this 1 over, so I get 4 equals negative 4t. Divide both sides by negative 4. T equals negative 1. So you can see that these t's are not equal. That means that there are no solutions. If the t's are equal, there are, I didn't write it here, beautiful. I'll write it in blue. If the t's are equal, there are infinite solutions. If the t's are not equal, there are no solutions. So here, system 2 has no solutions. So 3 different ways of doing it. This is the most inaccurate way, but let's continue. All right. Method 3. So here, same type of thing, but I give them in parametric form. So again, first thing I want to do is graph it. So here I can see line 1 goes to the point 3, 3. Where's 3, 3? 3, 3 is right there. Beautiful. And then I'm going to do the slope. So the slope is, my x value is 4. So I'm going to go over 4 to the right and then down 1 over 4. So I'm going to be at 7, then down 1. So I should have a point right there. Beautiful. And then I can draw my line. So let's see here. Beautiful. And I'm going to draw my line through those 2 points. That's not very good, but I can fix this a bit. All right. Let's see if I can. Still not great. There we go. There we go. All right, the other one, I'm going to start at negative 4, 2. Negative 4, 2 is right here. Where are you? And then the slope is over to the right 3 and down 2. 1, 2, 3, and down 2. Oh, up 2. My apologies. Up 2. And look at this. I don't have it, but I can actually put it here. So again, I made a mistake by saying going down 2, but it's plus 2, so I'm just going to go up 2. So I'll put a point there, and then I can draw my line. So here we go. Draw my line through this. Let's try this again. What a line. And there we go. And you can see this is not perfect, but it will do. There we go. You can see that my point of intersection here is right there. Solve using algebra, equate the x and y. So here I'm going to have 3 plus 4t, I'll write it here, is equal to negative 4 plus 3s. All right, so I'll bring the 3s over here, so I get 4t minus 3s is equal to, bring this 3 over, so I get negative 7. There's my first equation, that's the x's. The y's, I'm going to have, whoops, three minus t is equal to 2 plus 2s. I'm going to bring everything over. I'll bring this t over here, so I got 1 is equal to t plus 2s. And in fact, I'm going to use substitution here, because I can easily ace for t. T is equal to 1 minus 2s. I'm going to put this guy in for t. It's a terrible arrow, but here we go. So I get 4 bracket 1 minus 2s minus 3s equals negative 7. So I get 4 minus 8s minus 3s equals negative 7. Oops. Add these two like terms together, so negative 11s. Bring this 4 over, so it becomes negative 4, so I get negative 11. So s equals 1. Got my s. My t is equal to 1 minus 2 times s, which is 1. So t is equal to negative 1. So I have my t. And then I can substitute it back into my equation. Either one, line 1 or line 2, I've got s and t. So I really didn't need to solve for s and t, just one of them. So let's solve for t. T is the easier. Let's go with s. S is equal to 1. So here, I know I'm going to have my x's. Running out of room here. x is equal to, we'll go with line, let's go with line 1. So line 1, so x is equal to 3 plus 4t, 3 plus 4 times negative 1, so x is equal to negative 1. And then y is equal to, back up here, 3 minus t, so 3 minus negative 1, so so that means y is equal to 4. So I got my x, and I got my y, which is confirmed up here. Whoops, my point of intersection is negative 1, 4. Beautiful. I'll write over here, therefore, the POI is negative 1, 4. Beautiful. All right. Same thing with the second one. Look at the direction vectors. Are they parallel? So my direction vector here is 4, negative 1. My other direction vector here is 3, 2. I write them as ratios, so 4 over 3 and negative 1 over 2. These are definitely not equal. If no, of course there's no solution, and if no, there's one solution, sorry, which my solution is right here. If yes, substitute R naught into L1, from R1, sorry, into L2, and check if the T's are equal, which I did in the second example. If they are equal, infinite solutions, and they're not equal, there's no solutions. But I don't have to do that because I can see that there is only one solution, negative 1, 4. So here, system 1 has one solution. All right, just to review, just like grade 9 math, a system of equations can have no one or infinite solutions. If lines intersect at a point, there is, of course, one solution. If lines are coincident, which means one on top of the other, there are infinite solutions, and if lines are parallel, there are no solutions. Thank you for listening to lesson 4A.